Hello and welcome to my new video on the gamma function. In this special video we will derive the relationship to the zeta function, which you can see below. The gamma function multiplied with the zeta function is equal to this cool integral from 0 to infinity u s minus 1 and e u minus 1. This is looking pretty strange, but some parts are reminding us of the gamma function, so we might smell some relationship to the gamma function. Because of u to the s minus 1, we had something similar. We had t to the s minus 1 in the definition of the gamma function, and this part is strange looking, but the boundaries are still reminding us of the gamma function. So let's just start off with a definition of the gamma function. Okay, we have the definition of the gamma function from 0 to infinity, t to the s minus 1, e to the minus t dt. Very important, this representation only converges for s, or better, the real part of s being positive. Now we are doing a little substitution. Okay, t is equal to nu, while n is an integer number and is positive. Okay, or I think yes, it's an integer number and is positive. Because of that, the boundaries do not change. We still have 0 and infinity. If we implicitly differentiate this, this will give us dt, and this gives us n multiplied with du. So nothing big happened. We just replace this stuff into the integral and we get this stuff. Okay, we get nu to the s minus 1 multiplied with e to the minus nu multiplied with n du. Now you can see we have n to the s minus 1, but we will multiply with n, so we get n to the s here, u to the s minus 1 and e to the minus nu. Okay, what I do in the next step is let's look back. I will divide with n to the s. Okay, because n to the s is never 0, I can do that. We took positive integer numbers, okay, for n. So this is the reason why this is never 0. Now, this somehow reminds us of something, of the zeta function, okay? If you don't know what the zeta function is, then you can look into my videos. I will explain you what the zeta function is, and then come back and watch this video, because it doesn't make so much sense to look or to better watch this video if you don't understand the zeta function. Now what we are doing, this is only a part of the zeta function. In order to have the full zeta function, we would have to add over n from n equals 1 to infinity, and this is what we are doing. We are adding from n equals 1 to infinity, and the right hand side has to be added too. Okay, now let's look what happens. Here on this side we get the zeta function. Like I told you, this is just a definition of the zeta function. You can look it up in Wikipedia. You will see that this is really true. On the right hand side we will do a little trick. Because this integral is absolutely converging, we can change integral and sum, and then I can even take the sum to only add over the exponential, because u to the s minus 1 doesn't have an n in it. Okay, so we are only adding these exponentials. And now look at this. What is this? If you would write it out, it would look like e to the minus u plus e to the minus u squared plus e to the minus u cubed, and so forth. Okay, if we call e to the minus u is a, then we have a plus a squared plus a cubed plus a to the fourth, and so forth. Actually, this is the geometric sum. Okay, and as this is the geometric sum, we can use something. We can use the formula for the infinite geometric sum, and it is very important that e to the minus u is always smaller than 1. Okay, because u is only positive, so we have always smaller values than 1, and we can use the geometric sum, which gives us 1 over 1 minus e to the minus u, because this is our a, and because we didn't start at 0, we started at 1, we have to subtract 1. Okay, now you see, wow, this is looking pretty similar to the stuff that we had in in the first page, but we will look what happens here. I take this one and just bring in this the common denominator. So we have here 1 minus e to the u and 1 minus e to the u. So pretty simple what we did here. Now we can take both parts and add them together. Here in the numerator we get 1 minus 1, okay, this will give us 0, and minus e to the minus u will give you plus e to the minus u, okay, and here 1 minus e to the u. Now the last step that we have to do is we just multiply this this fraction with e to the u, and here we have to multiply it also with e to the u. Here we will get 1, and here we will get e to the u minus 1. Now look at this. This is the crazy integral that we had before, and this actually solves our problem and concludes our lecture. This is the famous relationship between gamma function and zeta function, which are both originally found by Euler and then used for other things to have a lot of cool other formulas. Okay, this concludes this lecture. If you want to see my new videos coming up soon, so please subscribe. Okay, and I think that's it for this video, so see you guys.